Welcome dear learners, this is Aishwarya, Assistant Professor, Department of Chemistry, St. Joseph's College of Arts and Science for Women, Osur. In this video, we are going to discuss about coordination chemistry. Coordination chemistry is nothing but is a branch of chemistry that deals with the study of coordination compound. Next one is the complex or complexes ion. The central metal atom bonded to a group of molecules or ions is a metal complexes. If it is charged, it is a complex ion. The compound containing complexes or coordination compounds. Mostly complex ions is a positive or negative charged species which contains a central metal atom and a suitable number of ligands. The central metal atom may be a zero, positive or negative oxidation state. The ligand may be either neutral molecules or anions or a combination of neutral molecules and anions. Depending upon the nature of the charge of the complex ion, it may be a cationic complex ion or anionic complex ion. Cationic complex ion has a positive charge while anionic complex ion is a negative charge. The molecules are ions coordinating the metal or the ligands. They are usually anions or polar molecules. They must have lone pairs to interact with metals. Ligands, the molecules are ions that surround the metal in the say complex ion. It must contains at least one unshared pair of valence electrons. So donor atom in the ligand directly bonded to the metal atom. So coordination numbers and shape of the some complex ion. For linear shape, the coordination number have two. The square planar 4, tetrahedral 4 and octahedral is 6. Next we are going to see about the types of ligands or classification of the ligands. The first one is the monodentate ligands. When the ligands donate a pair of electrons to the metal atom, these ligands are also called as the chelate ligands. For example, chloro, hydroxoamine and methylamine. So monodentate ligands also have a three classification: negative ligands, neutral ligands and positive ligands. Then the bidentate ligands, ligands that contains the two or more atoms, each of which can simultaneously form two electron donor bonds to the same metal atoms. For example, ethyl diamine and oxalato. For multidentate ligand, diethyl tetramine, EDTA for the example. Some common ligands in the coordination compounds. For monodentate, we already discussed water, ammonia, fluoride ion, chloride ion, cyanate, thiocyanate, hydroxide, nitrate. For bidentate, ethylene diamine and oxalate. Polydentate, diethyl triamine, triphosphate and EDTA. Some name of the some neutral and anionic ligands: aqua, amine, carbonyl, nitrosyl, and anionic fluoro, chloro, bromo, iodo, hydroxo, and cyano. The metal ions in the complex anions. Then iron metal called as the ferrate, copper, cuprate, lead, plumbate, silver, arginate, gold, aurate, tin, stannate. The same metal, same ligands, but different number of ionization when dissolved, it gives the different color. So next we are going to see about the oxidation number. The oxidation number of the central metal atom is defined as the charge that is carries as calculated by assigning the appropriate charge to the ligands and equating the sum of the charge on the central metal atom and the equal to the charge on the coordination sphere. So knowing the charge on the complex ion and charge on each ligand, one can determine the oxidation number of the ligand. In the coordination number, The atom that supplies the lone pair of electrons for the metal ligand bond is the donor atom. The number of these atoms is the coordination number. Some metals such as chromium 3 and cobalt 3 consistently have the same coordination number 6. The most commonly encountered numbers are 4 and 6. There are two common geometry for the metal with the coordination number 4, tetrahedral and square planar. By far most encountered geometry when the coordination number is 6 is a octahedral. Next one is the polydentate ligands. So polydentate ligands, the one molecule of a polydentate ligands form more than one metal ligands bond with the central metal atoms. So some ligands have two or more donor atoms. These are called the polydentate ligands or chelating agents. So example, ethylene diamine. So in polydentate ligand, ethylene diamine tetraacetate has a 6 donor atoms. It is a wraps around the central metal atom cobalt like an octopus. So example for the monodentate, bidentate and polydentate ligands. Then next one is the chelating. When a multidentate ligand simultaneously coordinates to a metal ion through more than one sigma electron pair donor site or a group, a ring-like structure is obtained. It is called a chelate and the ligand is known as the chelating ligand. The process of formation of ring is called the chelation. Chelate is also known by other name like metal chelate, chelate complexes, etc. Chelating agent is a multidentate ligand, for example, ethylene diamine, EDT ion, and oxalate ion. So examples for pyrines. So important biomolecules like hemoglobin and chlorophyll also are the for pyrines.